Now, quadratic function doesn't usually start with a simple x squared. Like, we don't usually work with quadratic function that look like this in vertex form. And in fact, very often, we will see a number in front of it, and it is to indicate the size of the parabola. So when we have a quadratic function that started with a constant in front of your x squared, the best way to make it work is to factor it out. Factor out the number as in like taking out the GCF from the terms. But similar to what we've seen in example 2, like the 2 examples that we did earlier, the constant term at the end is not part of the perfect square. And if this constant term is not part of the perfect square, we're going to leave it out and don't work on it at this moment. So in example 3, we have 2 quadratic function and both of them in standard form. We're going to convert each of them to vertex form. And we will do that by first taking out the GCF from these 2 terms only. Once again, the 166, this number here is not part of the perfect square, and so we don't need to take out the GCF from 166. So for now, take out the 5, and here we will end up getting x squared minus 12x. Once again, the 166, leave it outside. 5 times 12 equals 60, so I take out the 5, 60, take it out 5 times, that gives us 12. So this is exactly what we will have if I'm to expand it and simplify, group the like terms together, and you will end up with exactly these 3 terms if you expand it. But we are trying to convert it to a perfect square, and we can then look at this middle term, divided by 2, and that's the perfect square we will be using. 12 divided by 2, that gives us a 6. And in order to form a perfect square, we will square the number. Now here comes the tricky part. As you have added 6 squared to the question, for this perfect square to happen, we're going to do some offsetting at the end. But this time, we are not just adding 6 squared to it. We're adding 6 squared 5 times. So to offset the change, I need to take away the 6 squared for 5 times. And therefore, while the 3 terms inside the bracket will create a perfect square, these numbers here with 166 minus 36 times 5, I'll be using my calculator to work out the value. Well, since I don't have a calculator in front of me, I'm gonna just work it out manually. 5 times 6 gives us 30, and 5 times 3 equals 15, so that's 180, and 166 minus 180 will give us negative 14. That means I have a parabola. Vertex at 6 and negative 14, and its size will be 5 times as narrow as the regular size. Using the same concept, I can now complete the square for the next one. So here, once again, the 3 at the end, it is not part of the perfect square, and we will leave it outside the bracket. We will take out the GCF from the first 2 terms. So this will give us x squared plus 6x, and the plus 3 stay outside. As you can see here, since we're having a negative and a negative there, once I take out the negative, this becomes a positive. And now we need to get the perfect square. Let me put this back. we need to add this extra term, and then we will offset the new terms by subtracting what is being added. This perfect square that we need, this perfect square that we're going to add, comes from this middle term, 6 divided by 2, and this is the number we'll be using for the perfect square. And I will offset the new terms by subtracting 3 squared for that many times. So now the -7 stay at the front. These 3 terms here will create a perfect square, x plus 3. And then the last part, it is 3 minus 9 times -7, or 63. So 3 plus 63 will give us 66. And we have the vertex at -3, positive 66. This will give us a parabola that opens downward and goes narrower 7 times.